All right. So if you want to share your screen, Indigo, we'll take a look and see what you've got for day two, part one. That's different from the one that we did.
All right, here we go. Let me see. Let me get my code up. So in the original one, we what I noticed is that we were working with the actual values of the levels and I do remember we worked with the indexes, but where I took the turn, I guess, was I was working with just the differences between the levels to find whether it was a valid, like a working level, and it passed the test. So this is what I got. So I just started, usual const fs, and then, if the length of the levels is less than two, um, it's just like because the levels is just one array um of numbers. So as long as it's meets that criteria, then it's fine. And then for me, I was doing a lot of learning about methods
Uh huh.
because they were, unfamiliar to me, but I got a chance to learn about them as I was using them. So I stored the differences in the levels first by using the dot from method, where I stored the length of the arrays as an object. Um, and I did levels dot length minus one because we're not working with all the numbers, we're just working with the differences between them. So if it's five numbers, it's going to be four differences between the five numbers. And then I go in, we don't care about the value itself, but the index we are going to care about. And then we're going to do this to them. We're going to subtract the proceeding level from the preceding level. That's what I've been saying. And we're just going to do that through all the numbers. So what that pretty much did was create an array with the values of the differences the um between the levels. And then the valid range, what that's going to do is it's going to check, is the difference more than one, and is it less than three? So pretty much we did the dot every method, which takes every single level and it has to pass a test. So does it pass a test of the difference being greater than or equal to one? And does it pass the test of being less than or more than or equal to, or excuse me, less than or equal to three? Because if it goes above three, it is not valid. It has to be between one and three for the difference between the levels. And then I stored the variables all positive, all negative, which checks if all of the levels are going in the same direction. So they have to all be ascending or descending. It can't go ascending and descending. It breaks the rule. So I did that by also doing the dot every method by running a test on them and checking is all the differences greater than zero. And if they are, that means that it's a positive ascension, which means it's always increasing the whole time. And then vice versa for the negative. The dot every, if it's less than zero, it's going down and it's not passing the test. And then I say the variable same direction, which is pretty much, is it all positive or all negative? And learned with this because the valid range, which was checking between if it's one and three, that difference, and the same direction, it being all positive, all negative, because they both return a true or false, I can just write it like that instead of if valid range and same direction return true, else return false. I can just write it like that. I always thought that's pretty cool. And then I came down here and I did the try method. It started with the file content, reading through the whole file, um, and then I split the lines down by every new line. So then it becomes, instead of one big file, it becomes an array, a big array of each line being its own string. And then I set the safe report count to 0 because that's going to be our counter to just count up how many levels passed the test. And then for const a line of new lines, my names for variables is I gotta get better at that. But so for every single line of all of those strings, if you will, do this to them. I'm gonna save the variable report levels to, and I'm gonna trim down those strings by every white space. And what that does is it's gonna create a new array that's filled with strings that are numbers. So each string is going to be a number. We can't work with that because we can't work with strings. So we have to dot map number to then transform into numbers. So it becomes an array of strings to an array of numbers. And then we're like, if is report valid. So if all of those arrays, with the numbers pass this test that we did up here, with the parameter of how we just chopped it down to make it a clean array with number values, then you can start the count of how many levels passed the test. And then I ran it and it worked. I was so happy. So do it again. Yes. It's 606. And then I went over to, I was like, let me make sure it's the same number. And it was.
That's very good. That's a very efficient way that you did that. I like that.
Thank you.
That's very good. That was really good. How long did it take you?
Up until like 2 hours ago. I went through a moment, a few moments with it, just because I was trying to, I guess, do it like just for my mind. I was trying to formulate, well, what would be different? This, the code that we wrote with you was so clean and efficient. I was like, how can I go different with this? So then I just, okay, we're dealing with the value of the numbers. Okay, what about the differences between them? And I didn't need help from AI just with explaining the methods because I wasn't, familiar with them, but I was clear with not getting the answers, but just getting guidance. Like, don't tell me the answer, but what exactly is the dot every, because I'm thinking it's just every single one at the same time, but actually it's passing a test for every single element. It has to pass a test and it's going to give you a Boolean answer. I didn't know that, so I thought that was pretty cool to be able to learn a few of the array methods with this one.
That was my next question to you, actually, was where you came up with the every method, because we haven't gotten into that yet. And that will be coming up in 2 more challenges, I think. I want to say
Okay.
it's on day 10. Day 10 or day 9 that we'll start using the every method. I know we haven't gotten into it yet. It's a pretty good one, pretty powerful one. So other than what you showed me, what was your biggest struggle, or told me, what was your biggest struggle on this whole refactor that you did?
It was between just brainstorming how could I solve it differently, and then the other one was the syntax and like not being super good at it, but throughout the process of just like getting it explained to me, I got to practice good syntax and just with the the different methods, and then also being careful of the parameter. So not, because for instance, like I originally put here and like where report levels 2, I put new lines because I was just trying to do it off the top of my head. I'm like, okay, yeah, right, the file, the arrays, but it's like, no, that's just still the whole file. So just really understanding what each variable contains and how it'll give you a completely different answer. Because at first I did that and it gave me 0. I was like, that's not right. So then I was like, let me see, what did I put? And then I was like, oh, I need to use the more broken down version that the it can actually use, a value can use. So yeah, that was a long-winded answer, but yeah.
No, you fine. So based on the research that you did on refactoring this into a different way than how we had all done it together, how many different variations do you think you came up with that you could have redone it in, out of
Well,
curiosity?
the first one just, I don't know, it wasn't making sense. I was about to do something like, oh, instead of starting from the beginning of the file, I could just start from the end of each array and like go backwards. I was like, I'm gonna do dot length -1, and then I'm gonna do minus dot length -2, and I'm gonna just do that. And that did not make sense to me. So I went back to the drawing board. So in terms of how many differences I thought of, let me see. Another way I thought, I was thinking I was gonna start doing something with this down here. The actual, for every line, do this. I was trying to think of a way to um run a function on all of the lines down here for some reason, but I was thinking, no, where the meat and potatoes is happens up here. Because this, like I remember you saying, this is more like a validation type of problem. So messing with some down here isn't going to be what needs to be tweaked. Is what with the helper function that probably needs to be changed. So those are like the two other ones, going backwards from the end and then messing with the loop.
Well, I like it. You did good on it. I like it. So now I get to give you a harder one to do for next.
No, it
No,
took you 3 days. I'm just kidding. Thank you though.
no, that was good. You did real good on that. I liked it. You can stop sharing now.
Okay.
You want to show where you're at, Michael?
I'm gonna wait.
Okay. All right. Well, let me pull this up. I'm gonna give. Oh, hold up. Sorry. Here's what we're gonna. Here's what we're gonna do. Like I said, today is gonna be incredibly shortish because I am incredibly tired from a stupid long day. But here's what we're gonna do. We're gonna go over. Let me get Advent pulled up. What the next challenge is. There it is. And I would like y'all to. Um, I'll give you some little like hints, but I would like y'all to start working on it, and then on Wednesday we're gonna go over it together and see which one. I'm gonna build one out. You'll build one out, Indigo, and Michael will if you can get them both done in time. Um, and we'll go through it. We'll go through all three, hopefully three of them together, and see which one is the uh, most viable. Does that make sense?
Yes.
Okay, so you still get to play around with your research now. So let me share it. That one. This one. Okay, so this is what day seven, day seven, part one. So this is one. Do you remember what we did last time with time complexity?
Sort of. I
Okay.
I gotta relook at it again.
Okay. Well, we're not necessarily going to be using time complexity in this, but we are going to be using something a little new. And I implore you to, if you don't remember it, um, do your research like you did last time. But I'm just go over it real quick. So this one, the historians take you to like a familiar bridge over a river in the middle of the jungle. The chief isn't on the side of the bridge, though maybe he's on the other side. So when you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. So you ask how long it'll take. The engineers tell you that it only needs final calibration, but some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations, which is our puzzle input. So each line represents a single equation. The test value appears before the colon on each line, and it's our job to determine whether the remaining numbers can be combined with operators to produce that test value. So can we combine those to make that, combine those three to make that, and so on and so forth. Now, operators are always evaluated from left to right, not according to precedence rules. So furthermore, numbers in the equations cannot be rearranged. And glancing into the jungle, you can see elephants holding two different types of operators. You have an and you have a multiply. Only three of the above equations can be made true by inserting only those two operators, 190. So 10 and 19 only has one position that accepts an operator between 10 and 19. Choosing add or addition will give you 29, but choosing multiplication will give the test value 190. 32, 67, and so on and so forth. You go through them. Now we just need the engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. So in the above example, the sum of the test values for the three equations listed above is 3749. So we need to take our puzzle input and determine which equations could possibly be true and what's their total calibration result. All this good stuff. Okay. So I'm going to give you a little guidance on it. This is going to be recursive operator testing. Okay. That's going to require simulation and backtracking or recursion to test every possible combination. Now, and since the operators we're told that we can only do it strictly from left to right, we're gonna you can use a recursive function to explore all those possibilities. That's my little hint that I'm gonna give you on it. Excuse me. That's my hint that I'm gonna give you on it. We're gonna have to separate the test value from the operand list for each equation. So the before the colon and the numbers after the colon. So we're going to separate them and then make a function that takes the current index, which is the position of the next operator to be applied, and then the current remaining total. Excuse me. Wow. And then for the operator that's at the current index, you're going to have to try both the addition and the multiplication operators with the next number in the list. So recursively call the function for both results. Those are the little like hints I'm going to give you on it. It's actually a relatively simple one. And I'm very curious to see what you come up with. Are you familiar with the recursion? Do you remember them? Or remember
I
what it is? Sorry.
don't. Mm-mm.
Do you
It looks like I mean, I know it's not an object, but it looks like kind of the format I was hoping. And then I had a question. Are we going to be using regex with this?
it's up to you.
Oh, really?
That's what I said. Do it however you want to do it. Make sure your answer is correct. So,
Okay.
do you remember what recursion is, Michael? I vaguely remember it. Okay, so recursion in software development or coding, it's a technique where a function can either call itself directly or indirectly to solve a problem. So it's like essentially defining a problem in terms of a smaller identical instance of itself. It's heavily used in computer science and math. How else can I explain it? That's the best way I can explain it, actually. It's a function that just calls itself over and over again. So, so you're gonna have to use recursive function in this. And other than that, I don't care what you do. I'm very curious what you come up with. I'll put something together. Excuse me, I'll put one together for Wednesday. And I'm very curious. This is where you get to let your I don't know, investigate and learn and go hog wild on it. And I mean, heck, if you decide you want to do it in Python, go do it in Python. It doesn't really matter. But I'm very curious to see what y'all come up with on it. But you do have to use recursion in it. That's the one requirement. Actually, I don't think it'll work without it.
All right.
Do you have any other questions on it?
No, I'm just gonna research. You said recursive. Let me
Recursion. Here, I'll put it.
recursion.
It's up.
Recursion
Sandy.
operating testing.
I'm sorry, what'd you say?
You said recursion operating testing.
Recursion operating testing. Recursion in JavaScript, if you want to just search that, just recursion in software development, recursion in programming, coding. It should give you it should give you a definition like functions that that are able to call themselves over and over again.
Oh, that's what I also forgot to mention, that I was on W3 schools.
Oh, when you redid day 2?
Yes.
Okay, very cool. And you got some knowledge from there?
Mm-hmm. That's when I was trying to sift through the different array methods to see which one might work. I was on there.
Very cool. I'm glad. Use all the resources that are out there. If you need to use like AI, go ahead and use it. But I'm like, I don't know. I think for me, I gain more if I go to like back in the day, we had Stack Overflow. Stack Overflow was our AI, right? If you wanted something, you went in there and it was like an old joke, copy paste from Stack Overflow. That's where you got your answers from. Now it's I guess like Chat or Claude or Gemini or whatever anybody's using now. But they tend to like solve the problem for you and take all the learning out of it, in my opinion. So if you can get some knowledge from like W3 or any of the other resources, I mean, go for it. That's how you're going to retain, it's how you're going to learn. But you know how you learn best. So whatever works for you, go for it. Just don't use a large language model to just solve it all the way,
Right.
So you good? Yep. All right. Well, I'm sorry I'm cutting it way short. I'm incredibly like whooped from today. So that's what I'm curious to see what y'all come up with on Wednesday, and I'll have one to share also.
All
right, guys. All right.
See
Well,
y'all Wednesday.
I will see you on Wednesday.
Bye-bye.
All right. See you.